All right, continuing our discussion on brief overview of Java. Next thing we'll look at is control flow. So control flow is in many languages, basically the if and if else. So this is the syntax, if condition, then in curly braces, a block of statements to be done if the condition is true. There is also the if else format. So if condition, do something else, do something else. If and else have the keywords here. They can be nested in all sorts of ways. So you can have a if with an else, and inside that else you can have another if and another if else, and so on. And there is also a switch statement, a switch case statement, where you evaluate an expression, and based on the value of that expression, you choose between among several different paths, each for the different values of that expression. There are several types of loops. Here is a general syntax of a while loop. You have an initial state of the condition that would affect the condition, then the keyword while, then the condition, and while the condition is true, you enter the block, do something repeatedly, and typically you should have at the end of the block a statement or statements that update some property so that the condition is eventually false. So while that condition is true, the block is executed repeatedly. And there is also the for loop, which has a fairly concise syntax compared to while, but it's an equivalent representation of while. So you have a for keyword, then the initial state, semicolon, the condition, semicolon, the update statements, and the block or the body of the loop, inside it. I missed the curly brace at the end of the parentheses here. It should be there, like we had with the while right after the condition. Yeah. Often you'll see people saying the while and for are equivalent, and yes, syntactically they are, but semantically you should not use for in place of while and while in place of for. For should be used when you want a loop that will go over almost every element in a collection. For example, an array. We'll see the arrays in a minute. But those are the places where you should use for loop. While loop, on the other hand, can be used for those cases as well, but it should be used for places where you're not necessarily going over a sequence or something like that. A good example would be checking whether the user wants another input, and you may want to check the input string against yes. If it is a yes, go ahead, execute the loop body again, otherwise break out of it. A subtle difference, and I think it's important when using the language properly. Next thing is methods. And we'll also talk about method overloading. First, let's look at the example on the left, where you have a method called square for integers. Let's look at different elements of that method definition. So first of all, you have public, which is an access modifier. It means this method can be called from outside the class in which it is defined. Int here is the return type. It can be any type in Java, including void, which means the method is not supposed to return a value. Square here is the name of the method, and you will use that to invoke the method. Int num in parentheses is a list of formal parameters. There can be 0 or more formal parameters for a method, and these are basically placeholders for the actual values that will come in when you are invoking this method. And here is the method body where you do your computation or print things or whatever. Here we also see a return statement. Since this method is a non-void returning method, it expects an expression of type int to return. So compiler will check for you whether it has a return statement on every execution path inside the method body, and also whether the type of the expression of the return statement matches the declared return type of the method. In this case, it does. So we are good. This is not a compiler error. Let's see how this method is invoked. You can have a statement like int y equals square of 5. And as you expect, y should get the value of 25. But this is how the method is executed. 5 here is the actual parameter or an argument. And when the method is called, this value is copied into the formal parameters here. In this case, there is only one, but the mechanism is do a place-by-place matching. And if we have like 3 parameters, 3 formal parameters, the 3 arguments will be copied in the appropriate locations. Okay, then that value num goes inside the body and executes. And at the time of return, the method call expression gets the return value. So result is returned in the expression square parentheses 5, and then the assignment statement does the job of putting the value in y. Okay. Yeah. Now let's look at this method overloading. Overloading means a method having the same name but different formal parameters. So in this case, we have the method square in both places, but they differ in their parameter list. So one of them has int, another one has double. You can overload a method by giving a different parameter list in terms of number of parameters or the order of parameters or the types of parameters. An overloaded method, it simplifies certain aspects. So instead of naming methods like square int and then square double, you can just have square, which is a more logical name, and differentiate using the parameter name. And yeah, this is what makes this an overloaded method. Okay. Moving on to arrays. Arrays are aggregate data. Again, pretty much like C, but there are some checks and balances compared to C or C++ that are in place. It puts data in the consecutive memory location starting from the starting address, and you can access arbitrary elements of arrays by doing things like array square bracket and then index. That index should be within the appropriate range. The range is given by 0 to array.length minus 1 inclusive. Array.length is a free variable that you get when you create any array. Array name .length is how you can call it. Let's look at an example. Int square bracket r equals new int square bracket 4 will create an array of 4 integers, and the default values will be 0. So different types have different default values. Integers, doubles, they get a 0. Booleans, they get a false, and so on. Any reference types, strings, or any other, they get a null. Next, let's see how to populate this array. You can do a for int I equals 0 to I less than r.length I++. So this loop will go over each element in that array. And what we are doing is we are putting I times 2 in the ith location, ith cell of that array. So after executing this loop, our array will modify it to this 0, 2, 4, and 6. And now you can access or say print one of the values, say system out println our arr2. So that will give us 4. Indexing starts at 0. If you try to do something outside the index range, like in this case, then you'll get an index out of bound error. Next, let's talk about wrapper classes. So, when we discussed the primitive types, I said primitive types are not objects. That keeps certain things simple, executing arithmetic operations on ints, let's say, is very, very, very simple, very fast, and happens in the language directly. But it has certain disadvantages. The primary one being, if you want to create an aggregate type, a collection, say a list or a set of anything, it has to be a reference. So you cannot create a list of ints, you have to create a list of some objects. So primarily to overcome that problem, Java's generics, which let you create lists and all, were introduced introduced much later in Java 4, if I'm not wrong. So till that point they didn't have this problem, um, but once they were introduced, Java people had to decide what to do. Should they remove backward compatibility by just disallowing any non-object types, all primitive types, or do a workaround for incorporating primitive types in the new features? They went with the latter. It has its own pros and cons, of course. But anyway, so Java has these what are called wrapper classes for the primitive types. So capital I integer, capital D double, capital C character, all spelled out, and capital B Boolean, etc. They can take values from the primitive ints and doubles and so on, and they can output values into corresponding primitives. So this principle is called auto boxing and unboxing. The advantage of that is, you can have an integer object, and since it's a class, ideally you should be calling methods on that, like addition or subtraction methods. But to keep things simple, Java supports auto boxing and unboxing for these primitive types. So you can have a primitive type variable and primitive int, let's say, and just do plus and pass, and the second argument, or rather the second operand, could be an integer type reference variable. And Java doesn't fret about it. It simply works and gives you the result. Some commonly used static methods on wrapper classes are the integer .toString method. As you can see, you pass it an int, and it results in a string, which is a string version of that int. Opposite of that is the parseInt method, which takes a string with the numeric format and returns the equivalent integer. Of course, the requirement here is the string that you pass must contain the integers, rather digits, and the equivalent integer should not go out of the integer limit bound. Okay. And yeah, of course, you cannot do things like parseInt and the spelled out string 42. That will result in an error. Yeah. All of these are static methods. What are static methods? The methods that can be called on the class and not on an individual object, the methods that are common to all the objects of the class, in other words. So here you see these methods being invoked using the class name integer.toString, not say x.toString. Okay, so that's the key difference. All right, we'll pause here and we'll talk about the object-oriented concepts, inheritance, polymorphism, etc. in our next video.